talk about inscribed angles and polygons. Before we get into that, let me remind you of something that we've covered previously. If we have a circle, and let's say the center of the circle is here, and I draw an angle, and that angle has its vertex at the center, that angle was called a central angle. We've covered that before. That's not in today's section. This is just a refresher. Let's say that central angle was 75 degrees. If that central angle was 75 degrees, the arc that it creates would be the same. It would also be 75 degrees. That's what we covered previously. What we're talking about today is what we call an inscribed angle. An inscribed angle has its vertex not at the center, like a central angle does. It has its vertex on the circle, still can connect potentially the same 2 points. But this is called an inscribed angle. That's what we're looking at today. And I'll go back to the notes here in just a second. But here's an important thing to know about the difference between a central angle and an inscribed angle. The central angle had the same measure as its arc, but an inscribed angle, its measure is half of the arc. So it's still inscribed the same arc, 75 degrees, but I have to take 75, cut it in half. Unfortunately, I picked an odd number, but that's going to be what, 37.5 degrees. You would cut the angle in half, the arc in half, to get the inscribed angle. So that's what we're kind of introducing today. So let me go back to the notes. So we see here on the left, we have this inscribed angle. It's on the circle. And its arc here, that's the arc inside, we call it the intercepted arc. And then as I just said, the angle is half of the arc. So here's our arc AB. The arc, remember, the arc is bigger than the angle. So the angle is half of the arc, or you could say the arc is double the angle. So as we look at this example, you see that we have this 50-degree angle right here. If we follow that angle out, it goes to Q and T. So the arc in between those two would be its intercepted arc. If the inscribed angle is 50 degrees, the arc is double that. The arc is 100 degrees. Now, I haven't actually answered any of the questions they're asking for over here, but I'll get to those in just a minute. Let me also look. I'm going to change colors. Let me also look. We had a 48 degree, and that's an arc. Well, that's intercepted by this angle here, angle T, or angle RTS. If the arc is 48 degrees, we have to cut that in half to get the angle. That's a 24-degree angle. Now, that happens to be the first question they asked. So the angle is half of the arc. We want to remember that. Now, the next question they ask us is about a different arc from Q to R. So I'm going to put that in green here. From Q to R, we want to know how many degrees that is, but they don't give me an angle that's associated with it, or the angle that intercepts it. So we don't have a real great angle to look at. So what we have to observe in this picture, or right now, is they've drawn in a diameter. A diameter has to pass through the center. So from T through P over to R, there's a diameter right there. And we know that a diameter will cut a circle in half. If an entire circle is 360 degrees, a diameter cuts that into 180-degree sections. So if I look above this diameter, I already know this is 100 degrees. And if I have to have a total of 180 up there, then that must be 80 degrees. So that's the answer to the measure of arc QR. The next thing we want to look at, this next example, notice we have a 31-degree angle, but if I follow that 31-degree angle out, it intercepts the arc, or S. Now, there was another angle that intercepted that same arc. Angle T has the exact same arc. Now, let's go ahead and think about what the measure of the arc is first. So we had this 31-degree angle, so the arc would be double that. It'd be 62 degrees. That's the first question they asked me about. The measure of arc RS is 62 degrees. So I just had to double the 31. And then they ask about the measure of angle STR. That's the angle up here that I've already got this arc on. That angle has an intercepted arc of 62 degrees, so then I have to cut it in half to get the measure of the angle, so it would be 31 degrees. And then they say, hey, what do you notice about angle STR, the one we just found, and angle RUS, which was the 31? Oh, they're congruent. Which leads us into this next section. This next section says anytime that we have two angles that have the same arc, they're going to be congruent to each other. So you can see in this picture, arc AB, that's the arc made by angle D and by angle C. They both make the same arc, therefore they have to be congruent to each other. That's helpful to know.